Hi students, this is Sivakumar. 11th Standard Mathematics, Chapter number 3, continuation of exercise 3.1. Now problem number 5. This is a given condition. We have to prove these two results. Okay. Given condition, here it is, which implies the first subdivision all in terms of sign only, no cos at all. So, I am going to replace cos in terms of sign. So first we write cos power 4 alpha, that is cos squared alpha the whole square divided by cos squared beta plus sin power 4 alpha, let it be, divided by sin squared beta, that is equal to 1. We know the formula for cos squared alpha, that is 1 minus sin squared alpha whole squared divided by cos squared beta, that is 1 minus sin squared beta plus sin power 4 alpha divided by sin squared beta, that is equal to 1. Here you can cross multiply, otherwise you can take LCM. If we take LCM, LCM 1 minus sin squared alpha, sin squared beta into sin squared beta. Now here we will be getting sin squared beta into 1 minus sin squared alpha the whole squared. If we cross, we will be getting this term, plus if we cross, we will be getting 1 minus sin squared beta into sin power 4 alpha, that is equal to 1. Then sin squared beta, write as it is. Here you can apply a minus b the whole square formula, a that is equal to 1, b that is equal to sin squared alpha, that is a squared plus b squared plus 2ab, 2 into 1 into sin squared alpha plus 1 into sin power 4 alpha, sin power 4 alpha minus, multiply these two, sin squared beta, sin power 4 alpha, sin squared beta, sin power 4 alpha, right? Close the bracket. Divided by, that is equal to, you can cross multiply. If you cross multiply, you will be getting 1 minus sin squared beta into sin squared beta. Now this sin squared beta is common for all the term which is inside the brackets. So multiply sin squared beta into 1, that is sin squared beta, that is equal to which implies sin squared beta plus sin squared beta into sin power 4 alpha. See? Sin squared beta into sin power 4 alpha. Here 2 into 1, 2 sin squared alpha, sin squared beta. If you multiply these two, you will be getting 2 sin squared alpha, sin squared beta plus 2 sin squared alpha, sin squared beta plus sin power 4 alpha minus sin squared beta, sin power 4 alpha. Sin power 4 alpha minus sin squared beta, sin power 4 alpha, that is equal to, have to multiply these two, 1 into sin squared beta minus sin power 4 beta. Okay, if you multiply, you will be getting sin power 4 beta, sin squared beta minus sin power 4 beta. Okay, which implies here sin squared beta sin power 4 alpha minus sin squared beta sin power 4 alpha, these two get cancelled. Then here left hand side we have sin squared beta, even in right hand side we have one sin squared beta, these two get cancelled. Then what are the left out terms? We have 2 sine squared alpha sine squared beta, that is equal to, here sine power 4 alpha, here minus sine power 4 beta. Here one correction. Here you know the formula a minus b whole square, that is a square plus b squared minus 2ab. This is not plus, minus here. So if you multiply these two, you will be getting minus 2 sine square alpha sine square beta. Here you have to change the sign, not plus, here minus. So here minus sine power 4 beta. So minus 2 sine square alpha sine square beta plus sine power 4 alpha, this one, this comes left hand side, plus sine power 4 beta, that is equal to 0. Can write them in order. First I write sine power 4 alpha, that can be written as sine squared alpha the whole square, then sine power 4 beta, that is sine squared beta the whole square, minus 2 sine squared alpha sine squared beta, that is equal to 0. What form it is? This is of the form a square plus b squared minus 2ab. We know that a square plus b squared minus 2ab, that is equal to a minus b the whole square. Which one is a? Sine squared alpha minus b, this is b, that is sine squared beta the whole square, that is equal to 0. Taking square root on both sides. So you will be getting sine squared alpha minus sine squared beta. While taking square root, the square and square root get cancelled. 0 square root is 0. The next step, you can write sine square alpha, that is equal, it comes right hand side, plus sine square beta, which implies sine alpha, that is equal to sine beta. Once again, if you take square root on both sides, square and square root get cancelled, you will be getting sine alpha, here sine beta. Sine alpha, that is equal to sine beta. Let it be number 1. Here this result, sine square alpha the whole square plus sine square beta the whole square minus 2 sine square alpha into sine square beta equal to 0. I consider this is equation number 1. Okay, this is equation number 2. This one I consider equation number 3. Equation number 1, 2 and 3. Now equation number 1 implies, equation number 1, that is sine squared alpha the whole square, that is sine power 4 alpha, plus sine squared beta the whole square is sine power 4 beta. Okay, that is equal to this term, this expression, when it comes to right hand side, minus become plus, plus 2 sine square alpha sine square beta, that is equal to plus 2 sine square alpha sine square beta. Subdivision 1 is proved. Subdivision 1 is proved. Look at that. Subdivision 1 is proved. For proving subdivision number 2, I consider equation number 2. Equation number 2, here it is sine square alpha, that is equal to sine squared beta. Write this one, sine square alpha, that is equal to sine squared beta. Sine squared alpha, that is equal to formula 1 minus cos squared alpha, sine squared beta formula 1 minus cos squared beta, which implies 1 and 1 get cancelled, minus cos squared alpha, that is equal to minus cos squared beta. Even minus minus get cancelled, cos square alpha, that is equal to cos squared beta, which implies cos squared alpha, that is equal to cos squared beta. Taking square root on both sides. If we take square and square root get cancelled, we will be getting cos alpha, that is equal to cos beta. Let it be number 4. Now I consider subdivision number 2, LHS. What is in LHS? Cos power 4 beta divided by cos square alpha plus sin power 4 beta divided by sin squared alpha. Cos power 4 beta divided by cos square alpha plus sin power 4 beta divided by sin squared alpha equals cos power 4 beta can be written as cos power 4 alpha because cos beta and cos alpha are same. We have proved, right? So beta can be replaced by alpha. Denominator cos square alpha, write as it is. Like that, sin power 4 beta can be written as sin power 4 alpha because sin beta and sin alpha are same. In equation number 3, what we have proved, sin alpha and sin beta are equal. So this becomes sin power 4 alpha divided by sin squared alpha. That is equal to, if we divide, we will be getting cos squared alpha in the numerator, and here sin power 4 alpha divided by sin square alpha, that is equal to sin squared alpha. Sin square alpha plus cos square alpha, what is the formula? Value 1. So that is equal to RHS. Subdivision 2 is also proved. So question number 5 is completed. I'll be teaching the next problem in the next video. Thank you, children.